Okay, on 32 we have a quadrilateral, and within the quadrilateral we have endpoints in, I'll zoom in on it really closely, N, O, P, and E. Those are all midpoints, and we're trying to prove that the quadrilateral that is formed by joining those midpoints is a parallelogram. So here's the general idea, and the reason why I put the extra diagonals in here is that we're going to use the fact that if I just cover up this drawing, here I'll use a sticky note. All right, I'm going to cover up that part of the drawing. And then we have ourselves a triangle up at the top, and what kind of segment is NO in relationship to this new triangle? It's a mid-segment. That mid-segment is half as big as the third side, and it is also parallel to that side. We don't need the half business, but we do need the parallel business. This is going to be parallel to that diagonal. Now if I lift off this sticky notes, I can do the exact same thing up here at the top, and I have another triangle in which this is a mid-segment which is parallel to the diagonal. And then I'll just use the transitive property to show that those two mid-segments are parallel to each other. Right, and then I'll just do the exact same thing over here with NE and OP. Right, so that's the general idea. Yes, Sammy?
In a parallelogram, does the sides have to be equal? But how
right, now, in order for me to prove that a shape, a quadrilateral, is a parallelogram, I don't have to prove that the opposite sides are parallel. I just need to pick one of the criteria. Showing that the opposite sides are congruent is one of them, but also by definition, if I just show that the opposite sides are parallel, it would make a parallelogram, and then by the properties of any parallelogram, its opposite sides were congruent. I would get that part for free. So I don't have to do both of them, I just pick one of them. And on here, the easiest way to do it is by just showing that the opposite sides are parallel to each other. All right, so we'll just do a straightforward, good old-fashioned two-column proof. Statements and reasons. Wow, I hope there's enough room. I sure am writing kind of large. All right, so the first one is that we have this quadrilateral ABC, D, where we have N, O, P, and E being endpoints, with N, O, P, and E are midpoints. And that's just given. Now what we did is we are able to show that, like when we put in our diagonals here, NO becomes a mid-segment, and that NO is going to be parallel to that diagonal AC. So that's what I'm going to state on the second one, that NO is parallel to AC. What theorem is that? Yeah, it's mid-segment theorem. Now, together with that one, I can put on the same line, because it's dealing with the same set of segments. I can also say that EP is parallel to AC as well. AC is parallel to EP. And then you can see that I've got this set up to be like a transitive property. Transitive property, if you don't remember, works with numbers and congruence and also with parallel lines. If A is equal to B, B is equal to C, therefore A is equal to C. I can do the exact same thing with parallel lines. NO is parallel to AC. AC is parallel to EP, therefore and that is the transitive property of parallel lines. Now I just have to do step 2 and 3 one more time with the other two sides of my quadrilateral. Right, so step 4 is going to be that NE is parallel to BD. and BD is parallel to OP. And its reason? Oh, good. And over here, step 5, we're so close. NE is parallel to BD. BD is parallel to OP, therefore, by the transitive property again, and then finally, if NO is parallel to EP, and EP is parallel to, okay, that's right. NE is parallel to OP. These are our two opposite sets of sides being parallel. What type of shape is that? That's a parallelogram. So on number 6, nope, is a parallelogram. And what criteria did we use to prove that it's a parallelogram? Yeah, the opposite sides are parallel. You can state that the opposite sides are parallel, or you can just say that that's the definition of a parallelogram. I'm going to do a dramatic pan across this 2-column proof. And then let's zoom in.